Hey everyone. In today's video, we're going to be taking a look at a little introduction into systems of linear equations. Here we see just a general definition, which means that a linear system is a collection of two or more linear equations with the same set of unknowns. So in this set of videos, we're going to be focusing on two equations with two unknowns. As you go through Algebra 2, you can also come across three unknowns, four unknowns with three or four equations in your system. But we're just going to focus here on two equations with two unknowns. Okay, and here's a general example of one. Y equals 2x plus 1, that's a linear equation, and y equals x plus 5, that's another linear equation. All right, so the other piece that I want to talk about in this video is just how to check to see if your solution is a solution to the system. All right, the way you do that is when you're looking for a system of equations, the point that we see here is actually the point of intersection if you were to graph these two equations. Now what we're doing is we're trying to figure out if that's true, if that point is actually the point of intersection when you were to graph or solve for the solution to these systems. All right, the way you do that is you would just plug it in and check to see, just like we did with equations in the beginning of the year. Okay, so we have an x and a y in each of our equations. What we're going to do is plug it in to each of our equations here, and we're going to see if we have solutions or not. Okay, so in the first one, I plug in a 3 for y, 4 times 3 minus 9. Okay, so I get 3 equals 12 minus 9, 3 equals 3. So that one's good, that one checks out. Okay, now let's check the second equation. Okay, the second equation is y equals x minus 3, so it's 3 equals 3 minus 3. We get 3 equals 0, which is not a solution, okay? So for this one, this would not be a solution because we do not have both of our equations being correct, okay? So in order for a system of equations to be a solution, or to have this solution, okay, they must both be correct equations. 3 equals 3, yes, that checks out. But as soon as we get to the second one here, you can see 3 does not equal 3. That means that this is not a solution. Okay, let's take a look at the second one. Okay, so we have 4 comma 3. Again, we're going to plug in what we have. So we have 2 times 4 minus 3 times 3 equals negative 1. Okay, so this is 8 minus 9 equals negative 1. And we get negative 1 equals negative 1. So that's good. Our first one is a solution, but we still need to check the second one to make sure that that one is also a solution. Okay, so we have y equals x minus 1. Okay, again, our points are 4 and 3, so it's going to be 3 equals 4 minus 1. 3 equals 4 minus 1, which is 3. Okay. And that one also checks out. So if you notice on this one, both of our equations check out as solutions. So this one is a solution to the system. Okay, so again, it's very similar to when we were checking solutions to equations in the beginning of the year. You would plug your x back in to make sure that it satisfies the equation. In this case, because it's a system of equations, the x and y have to satisfy both of your equations, okay, as opposed to just one. So the first one, again, not a solution based on the fact that the second equation did not match up, but for B, it is a solution because we have true statements when we plug back the x and the y.